In the last video, two of the joints were difficult to make, and we had to estimate the distance of movement after we have chosen the snap points. In this video, we're going to demonstrate how we can make snap points when the snap points we want are not automatically created for us. We're going to do that by looking at how to create a proper snapping point for this pin inside the piston, and then for this rotor end next to the crank itself. So we begin by doing the piston. Now, in the piston, we didn't have any problem getting a center snapping point on the piston pin itself. Our problem came from the piston. So the first thing we do, we are going to we are going to make a construction plane, and in that construction plane we will create a circle inside which the snapping point will be resident by creating a snapping point. So we construct, what we are going to do here now is to construct a plane through two, we want to construct a plane through two faces. Let's say, so a mid plane. So we are going to construct a mid plane. So we capture the position here, and the mid plane we want to construct is between here, and we want to go around to the other side. Let's see whether we can choose that other side. That other side is not okay. Yes, and this other side. Okay, so we have taken two. So we want to construct a plane between those two. So we are going to do a sketch on that plane. Create sketch. The sketch we are going to create will be on this plane we have just created. And this plane is not showing, it's being blocked. So how do we choose it? Oh, okay, I can choose it. Okay, that is the plane. And the thing we are going to do on that plane is that we are going to create a projection. So we're going to create a projection. So create projector. So what we want to project there is this circle. So we want to project that circle to the plane. And once we are happy with that, it's convenient for us to switch off the body. And then this is so we can now say create a circle, create a center circle, or create a circle. I don't want to create a center diameter circle. I want to create a circle with 3 points. Create a 3-point circle. And I will just choose 3 points on this circle. This is 1 point. This is another point, and this is a 3rd point. So that is the 3-point circle. Because you realize that the point we are looking for is not the origin. The point we are looking for is the center of this circle. And ordinarily, all the time we were drawing, we were being pointed to this, which was the wrong place. So the next thing I want to create is a point. I want to create a point here. Create a point. And that point is the center of this circle. And once I finish that sketch, I say, I'm okay. Switching off everything apart from the piston and its pin, we are now able to use the snapping point that we have just created. The snapping point created is in the mid plane, is in this mid plane on this piston. If we want to take a look at it directly, we can rotate this and come down here and see this is the snapping point that we have created. In some cases, it might be easier to see it rather than walk through the solid object that is lying between it. But no matter how you do it, let us do it like this. We can now say assemble, joint, and the snapping point here is always available. We create that snapping point, and the second snapping point is the one here, and then we can say we want those two snapping points, and we want a rigid motion. If we say okay, that is it. So we have now used a snapping point that we created that did not exist previously. Now we're in a position to create the snapping point for the end rotor to the crank itself. And as before, we're going to create a sketch, and we want that sketch to lie on the crank itself, to move with the crank when the crank moves, and to always stay with the crank. To achieve that, we're going to bring the focus onto the crank itself. And now when we create sketch, that sketch is going to be lying on the crank. And then we're trying to choose this surface to create the sketch on. That is the back surface there. So we're creating a sketch on that back surface. And the first thing we shall do is to do a projection. So we do a projection, project. I want to project this circle that is on the rotor onto that sketch. So after that, we create a centered circle, a centered diameter circle, and that centered diameter circle is centered here, and we deliberately make it a smaller circle than that to distinguish from it, to distinguish it when we are needing it. So, finish sketch, and we can go back home now. We're back home. So, we take the focus back to the main component, and then we can see all the components in full. So we now assemble and say joint. The joint we want here is the center of this circle, and then the next one is the center of the circle that we have just created. So, and it is saying it is sliding. We don't want it to slide. We want that motion to be a revolute motion. We want a revolute motion, and then that is a revolute motion, and that's what we want. And you can see in this case, we do not have to make any guesses. It is snapped to the correct point and with the correct motion. The next thing we will do is to put the big end of the connecting rod into the crank position for it. And then we say assemble again, joint, and then we are going to choose this middle point here. That's the middle point, and then we are going to connect it to this one, and it already knows it is a revolute joint, and that is okay. Next thing is to take the crank and to take the piston pin and connect it to the small pin of the crank. The piston pin to the small pin of the crank, and this is where we are taking it. So assemble, joint. We're taking it from this point here, and then we are going to put it at this point here, and then that is the kind of motion we want, and we say it's okay, and we go home. And you know, for all the things we've done so far, if we try to move this, it moves everything. But if we fix the rotor end, let us see the rotor end. We fix the rotor end by grounding it. We can capture this position and ground it. So in that case, if we try to rotate this, everything rotates now. But we can't move, and we can't move these things from their position. Okay, so let us get it back to the position. The next thing we do is to now do the motion with respect to the cylinder. So joint, and then let us take the middle point there, and let us take it to the middle point here, and then we want a slider motion. Okay, we're happy with that. And the next thing is to ground the cylinder. Cylinder is grounded. And lastly, we can now test and animate this one. Okay, so that is the kind of animation that we want. Thank you.